So the definition of a circle is a lot like the definition of a sphere. It's the set of all points, but instead of all points in space, it's all points in a plane, because a circle is only 2D. The set of all points a given distance from a given point. So if you collect all the points that are 3 inches from A, all the points that are 3 inches from A, and you collect them, and you keep collecting, and you keep collecting, and you connect the dots, you'll come up with a circle. So that is the definition of a circle. Going back to notation, you know, when you want something to be a line, you put a capital letter, and you put a line with arrows on top. Well, if you want to tell someone that something is a circle, you take the center and you put a circle in front of it. So this means circle A. So you're always going to name a circle by its center, by whatever point is its center. So there we've got a picture of Tycho. It's a lunar crater, and it looks like a perfect circle to me. I mean, look at what nature did. It made almost a perfect circle. 85 kilometers in diameter, so very, very big crater on the moon. All right, the next word, a segment from the center to a point on the circle. We know this word. It is radius. So a radius is a segment, so we're going to name it with a capital A, a capital B with a segment on top. So radius is just a segment from the center to any point on the circle. So how many radii does a circle have? Infinite. Very good. Infinite number of radii. All right, the next word that we already know is the distance around the circle. Distance around the circle is circumference, also known as 2 pi r or pi d. There's an example of a time you would need circumference to create the molding around that window. You would need to know how much materials to cover the whole distance around that circle. All right, the next word we haven't talked about in this class yet. 2 points on a circle and the continuous unbroken part of the circle between the 2 points. So if I pick point B and point C, and when I talk about the unbroken part of the circle between those parts, I am talking about a arc. A-R-C, an arc. So an arc is like a segment of a circle. Well, no, that's a totally different vocab word. But an arc is a portion of the circle. So there's an arc in real life, the Clyde Arc in Scotland. Okay, now there are different types of arcs. So let's go over the different types of arcs. So we've got an arc whose endpoints are the endpoints of the diameter. So this arc right here. So if the arc is exactly half of the circle, we call it a semicircle. Sorry about lag. Sorry. Semicircle. An arc that is exactly half a circle, and its endpoints are the endpoints of the diameter. Oh, you're talking about their lag, the typing, not me, huh? Now, what's important to know is that notice how we named this with 3 letters, B, D, C, so that we know which way to go around the circle. Because if we just called it arc BC, we wouldn't know, are you talking about the pink arc or are you talking about the teal arc? Which one are you talking about? So using 3 letters helps us know whether to go to the left or to the right. So a lot of times, but not every time, a lot of times we use 3 letters to name a semicircle. All right, so then what happens if an arc is smaller than a semicircle? If it's smaller than half of the circle. So that black arc right there, arc BC, is smaller than half of the circle. The crust on this piece of pie is smaller than half of the circle, so it's named a minor arc. So a semicircle is halfway around. A minor arc is less than halfway around. It's kind of like an acute angle. Semicircle is to right angle, as minor arc is to acute angle. Does that apply to the normal arc? So the normal arc is like saying the word angle. I can define an angle, but now I'm going to define different types of angles. I can say arc, and now I'm going to define different types of arcs. So we've got a semicircle, we've got a minor arc, and what do you think is the next one? What's the opposite of a minor arc? A, there we go. Major arc. So, asking me when you would just use a plain old arc is like asking me when you would just use a plain old angle. First, we have to define the word arc so that we can even have a major arc and a minor arc. We're just defining that word. An arc is a portion of a circle, and there are different types of arcs, so I hope that makes sense. A major arc, you have to use 3 letters to name it. You have to use 3 letters to name it so that you know which way to go. So BCD is a major arc. The letter C is a major arc. A major arc because it's more than half of the circle. So really important. With a minor arc, we use 2 letters most of the time. With a major arc, you have to use 3 letters. No option. Have to use 3 letters. All right, the next word is something that you probably talk about if you're in band or in music of any sort. A segment whose endpoints are on the circle is called a chord. So segment BC is a chord. Chord. Hopefully these are in the same order as the ones on your sheet, are they? I hope so. Okay. Now, if you're an extra special chord, if you're a chord and you happen to go through the center of a circle, you're called a diameter. A diameter is a chord that happens to go through the center of a circle. So a diameter is a chord. It's a type of chord. A radius is not a chord. So there is a difference. A diameter is a chord. A radius is not because its endpoints are not both on the circle. So when you say, I'm ordering a 12-inch pizza, that 12 inches is how far it is from end to end through the center. You're ordering it based on its diameter. Okay, the next word is a line that intersects the circle in 2 points. So it's like you take a chord and you put arrows on it. So you take a chord and you make it go on forever and ever and ever and in both directions. So when you turn a chord, which is a segment, into a line, it is called a secant. The way you say that word is secant. So that is secant BC. Yes, it contains a chord because it is the chord is the segment inside that line. Okay, the next one is a word that we've heard before in trigonometry, but I don't want you to associate this word with that word in trigonometry. It's a totally different part of the word. So this is a line. This is really important. You're going to use this a ton in pre-cal and calculus. A line that intersects the circle at a single point. So it's like a line that grazes a circle. It just barely touches it. It touches it only once. It doesn't touch it twice. It doesn't touch it 0 times. It skims the circle. It skims it. This is called, you got it, a tangent. So if you've ever heard a teacher say, oh, we've gone off on a tangent. Have you ever heard that? I don't know. Maybe just math teachers say that. But it's kind of like, here's your conversation. Here's what y'all are talking about in class. You're talking, you're talking, you're talking. And then if your teacher says, we went off on a tangent, you went this way. You left the conversation and you went off on a tangent. That's what it's talking about. At point C, you left the circle and you went on to the tangent line. Yeah, okay, I'm glad it makes sense now. Okay. Tangent. Now, a really important thing about a tangent, did you take a look at this picture? Were you looking at it closely? A really important thing about a tangent is that it's perpendicular to the radius. It's always perpendicular to the radius. So you're going to get a right angle there, and we will look more into that later. All right, next word. This is going to make a lot of sense. No, I'm not being sarcastic. It's a very common sense word. The point where the tangent line touches the circle is called the point of tangency. Yep, very good. The point where the tangent line touches the circle is called a point of tangency. So I put this picture in here because here's like a tangent line to a circle. You see the circle? And there's the point of tangency. It's the one time that that tangent line touches the circle. All right, the next one, we're going to move into the different type of angles that you can have in a circle. If you have an angle in a circle, and the vertex of that angle is the center of the circle, like think hands of a clock. If the vertex is the center of the circle, it is called a central angle. That makes sense, right? The vertex is the center, so it's a central angle. Center, central. So angle BAC is a central angle. And we're going to learn this later, but I'm going to go ahead and tell you right now. The central angle, let's say that's a 27-degree angle, has the same measurement, the same degree measurement as its arc. So a central angle has the same measure of its arc. You'll need to know that later, but might as well put it in your notes now. Central angle has the same measurement as its arc, as its intercepted arc, but we'll get to that later. All right, so central angle is one of the types of angles we can have. Now we can have an angle whose vertex is not on the center, its vertex is on the circle. So this angle, its vertex is on the circle, so it's called an inscribed angle. Remember inscribed inside? So BDC is an inscribed angle, not a central angle, an inscribed angle. And we'll learn more about this later as well, but an inscribed angle is actually half of the measure of its intercepted arc. Half of the measure of its intercepted arc. 60-degree arc would make for a 30-degree inscribed angle. If I'm going too fast for you, I promise I'm recording. All right, if I have two circles that have the same exact radius, then, this is really common sense, they are called congruent circles. So if you want to prove that two circles are guilty of being congruent, you would just have to prove that they have the same radius. Two circles with, because that's the only thing you can measure of a circle. It doesn't have a length and a height and a slant height. It just has a radius, which is really just a component of the diameter, right? But once you have the radius, you have the circle. Once you have the radius, you've got the whole circle. Okay, moving on. This one's a fun one. Coplanar circles, so circles in the same plane that have the same center, but they're not congruent circles, are an example of, do y'all know what these are called? It's the Target logo. It's like when you drop a water droplet in the pond, it makes concentric circles. Yeah, ripples. You're funny. Concentric circles. That's the name of this one, concentric. Circles with the same center. Now they're not going to have the same radius, but they're going to have the same center. Concentric circles. Practice saying it. Say it 5 times fast. Concentric circles, concentric circles, concentric circles, concentric circles. It's hard to do. All right, so this was going to be the warm-up, but we have a lot to do today, so we didn't really do this together. But let's do it right now. AC. What is AC called? Give me a vocab word. Diameter. What's BC called? A minor arc, because it's less than halfway around. What's ABC called? I know I'm answering too quickly. Now, be careful. CR, do you see that that has arrows? They're very small, but it does have arrows. So it is a line, and it is specifically a tangent line. So point C would be the point of tangency. And lastly, AB. Now this one does not have arrows. It does not have arrows. So if you're trying to decide if it's a chord or a secant, it would have to be a chord. Because a chord doesn't have arrows and a secant does have arrows. Okay, so that's all that we're doing for this lesson right here.